Hello everyone, welcome to eTech. In today's video, we are going to learn about the Bourdon Tube Pressure Gauge, including its components, working principle, types, advantages, and disadvantages. At the end of the video, we will also understand why some pressure gauges are filled with liquid and why a siphon tube is used. Bourdon tube pressure gauges are among the most widely used instruments for measuring pressure in industrial and mechanical systems. From water pipelines and air compressors to boilers and hydraulic systems, these gauges play a critical role in ensuring safe and efficient operation. They can measure pressures ranging from approximately 0.6 bars up to several thousand bars, depending on their design. How does a Bourdon tube pressure gauge work? The Bourdon tube pressure gauge operates on the principle of elastic deformation, which means a material changes shape when a force is applied and returns to its original shape when the force is removed. The main sensing element is a hollow metal tube with a non-circular cross-section, usually bent into a C shape. When pressurized fluid enters the tube through the pressure socket, it exerts force on the inner walls of the tube. Because of this internal pressure, the tube experiences stress, causing it to deform and change its original shape. At the same time, the curved tube tends to straighten due to the applied pressure. This straightening effect causes the free end of the tube to move slightly outward. Although this movement is very small, it is directly proportional to the magnitude of the applied pressure. This small displacement is then transmitted and amplified through a mechanical linkage system, allowing it to be converted into a readable pressure value on the dial. Now let's look at the main components of a Bourdon tube pressure gauge. It mainly consists of 5 components. The first and most important component is the Bourdon tube. This is the sensing element of the gauge. It is a thin-walled metal tube with a non-circular cross-section, usually bent into a C shape. When pressurized fluid enters the tube, it deforms and produces motion. It is typically made from materials such as phosphor, bronze, stainless steel, or beryllium copper. The second component is the pressure socket. This connects the gauge to the system and allows the pressurized fluid to enter the Bourdon tube. The fixed end of the tube is attached to this socket. The third component is the linkage mechanism. This is connected to the moving end of the Bourdon tube and transfers its small movement to the gear system. The fourth component is the sector gear and pinion. These components amplify the small motion coming from the linkage. The sector gear converts the motion into rotation, and the pinion transfers it to the pointer. The fifth and final component is the pointer and dial. The pointer is attached to a spindle and moves over a calibrated dial, indicating the pressure value clearly. There are 3 main types of Bourdon tubes. The first is the C-type, which is the most common and widely used. The second is the spiral type, which offers higher sensitivity. And the third is the helical type, which is mainly used for high-pressure applications. Now let's look at the advantages of Bourdon tube pressure gauges. They have a simple and durable construction. They are low cost and easy to maintain. They do not require any electrical power to operate. They are reliable and safe for high-pressure measurements. And they provide good accuracy, especially at higher pressure ranges. However, there are also some disadvantages. They respond relatively slowly to rapid pressure changes. They may show hysteresis due to material properties. They are sensitive to vibration and mechanical shock. The displacement of the free end is small, so amplification is required, and they are not suitable for very high precision measurements. As we mentioned at the beginning of the video, let's now understand why a Bourdon tube system uses a siphon tube and why some pressure gauges are filled with liquid. A siphon tube is a curved pipe installed between the pressure source and the pressure gauge, especially in steam applications. Its main purpose is to protect the Bourdon tube from high temperatures. When the system starts, the siphon tube traps a small amount of liquid, usually water. In many cases, it is also filled manually during installation to ensure proper operation from the beginning. This liquid forms a barrier between the hot fluid and the pressure gauge. As a result, the high-temperature fluid cannot directly reach the Bourdon tube, preventing damage. In addition, the siphon tube helps reduce sudden pressure fluctuations, which improves the stability and lifespan of the gauge. Some pressure gauges are filled with liquids such as glycerin or silicone oil. These are called liquid-filled gauges. The liquid helps reduce vibration and stabilizes the pointer movement. This makes reading easier and more accurate. It also protects the internal components from wear, moisture, and corrosion. So this is how a Bourdon tube pressure gauge works. If you found this video helpful, don't forget to like, share, and subscribe. And feel free to leave your questions in the comments.